OpenCV weekly webinar, and today we are going to cover the OpenCV Spatial AI Competition sponsored by Intel and Microsoft Azure. So we are going to look at some of the people who have made it through the finals. And we also have with us Gilles, who is from Cortic Tigers. They are the ones who won our last competition. They were the judges of this year's competition. Thank you so much, Ye, for doing this. And also with us are Anna Petrovicheva, who is the CTO of OpenCV.ai. She's also very actively involved in OpenCV.org. And for this competition, she basically did manage all the judging for us. And with us also is Brandon Gilles, who is the CEO of Luxonis and the chief architect of Oak, responsible for all the good things that have happened with Oak recently. All the things have been shipped on time, before time actually, 4 months before time in some cases. So we'll learn about the competition, but we'll also learn about what Cortic Tigers is up to these days. We'll get an overview. So let's get started. Brandon, do you want to start with a few words and then how things are with OAK-D, OAK-D Lite, and all the various variants so that we can just get warmed up before we jump into the competition details.
Yeah, absolutely. Well, I'm super excited about this competition. It's fun to see, Legos being used to solve, all sorts of other problems that would be actually like pretty substantial engineering efforts. With OAK-D Lite, this fits extremely well. Let's see if I can find mine. They're so tiny, they disappear. It fits really well with Legos because our intention is to make it so that anyone can access these. And with Cortic Technologies drag and drop interfaces, you can literally have elementary school kids, middle school kids, not only perceiving the world like a human with a robotic system, but then actually doing really cool things with that, right? Like having a robot that responds or draws something or makes something or does a scan. So yeah, the OAK-D Lite, for folks who don't know, is a little, it's a depth sensor. So it gives you 300,000 depth points at over 30 frames a second. You can configure it up to 200 frames a second. It gives real-time AI, so you can know what objects are in real time, and then you combine that with depth information to know where they are in physical space. So that lets you mimic basic human-like perception, which is what allows you to grasp things and dodge the ball that's thrown at you. So now you can make little robotics projects that have all the basic understandings of a person. And it has a bunch of the vision functions that human eyes have as well. And when you tie that all together, you can do really interesting things like make a little robotic dog, for example, that will respond just like a normal dog. And so that's what we're up to. We're also in the process of releasing a bunch of other models based on customer feedback. Some models that can see in the dark, that can do depth sensing in the dark, so no ambient light, have power over Ethernet interfaces and IP67. And then just a whole bunch of things as folks interact with us on the community, on our Discord, constantly coming up with new ideas and trying to get those out to folks as quickly as possible.
That's great. I have actually, I had bagged, personally bagged, not through the company or anything, 10 OAK-D Lites during the Kickstarter campaign, just so that it was in time for Christmas to give out gifts to give to friends, some friends and some, kids of friends who are 12, 13-year-olds. I just want to see how they do with the device. So
did you get them on time?
I sent them. I shipped
okay.
them. Yeah,
great.
Already. Yeah. So we'll find out how they're doing. Actually, before we go to Anna, because she is the one who pretty much was, managing the judging of the process, I want to get a quick update from Cortic. If you could give us, how things are. Basically, I think the idea of this competition for using Legos might have come from your submission, because you were using Lego robot for your final submission. And somebody at Intel had this great idea that, oh, why don't we use a manufacturing solution using Legos? So you might have been the inspiration for this competition as well. We don't know for sure, but there's a good chance.
Yeah, thank you, Satya. Yeah, Lego is definitely a very powerful tool when you're trying to experiment and rapidly prototype something, even in the industrial sense. For us, we in the previous competition we concentrated on making a Lego robot for kids to learn how to use AI and program things in a visual programming language. But now in this competition, extremely excited to see that Legos are being put to use to prototype industrial applications. So there are lots of interesting entries from this competition that talk about the possibility of building a miniaturized version of something that can someday be in a factory or something. It's very, very exciting. If we can do the prototyping fast and easily, we can avoid a lot of the practical problems that we see when we go into a factory setting. So this is the goal that we're trying to achieve as well. For us, after the competition, what we're trying to do is pretty much making AI run much easier on the OP. So what we're planning to do is to have to produce a cloud-based platform to allow cloud-based management platform to allow users to deploy models and deploy apps to the OP devices, the entire family of OP devices very, very easily. At the same time, they should be able to write any vision, natural language processing, and Lego control algorithms on that platform using the click of a few buttons, as opposed to typing in commands in a command line. So I believe that Brendan and I are going to be working very closely in the coming year to make that happen. Well, all I can say is stay tuned. Hopefully it's going to be, you guys are going to see it and use it in the near future.
Yeah, like I said that, I wanted to also gauge how much 12, 13-year-olds they are able to pull off. But with your system, with the software that you have built, it becomes very easy for a lot of kids, even younger, I guess, to play with this new robot, right? So it will be exciting to see what you guys built as a finished product.
Yeah, absolutely. So one of the things that I love about the OP Lite is that it's so user-friendly. People are not scared about taking it into their hands and putting it onto a robot, especially those bumper cases that Brendan built. It just makes the whole thing very fun to play with. So again, kudos to Luxanis for making this happen.
Yeah, in fact, I had written some tutorials, and I was they were basic tutorials, but I was worried that things might break or I'll need to spend some time. It just worked out of the box, so which was written for OP.
So I volunteer for Hour of Code, and that's one of the things that it's really exciting about what Cortic technology, what you're building around this is. I think in a year's time, when I volunteer for Hour of Code, which we teach first graders, the basics of programming, I think you'll be able to have a Lego robot that a first grader can poke at and have it do cool things, which I think can plant the seed of interest in programming very, very young. So we're quite excited to work with Cortic technology to make this happen. Back to you, Satya.
That's great. Well, now we have the star of the show, Anna, who I just wanted to get your opinion on, Anna, your thoughts on the submissions in the competition. What did you find surprising? What are the kinds of submissions we got in this competition?
Yeah, thank you, Satya. So first, I love being kind of a judge of these competitions, because when you read through the ideas, when you read the papers that people submit, it's an amazing feeling, I can say. So you get inspired, immediately, because people may have so many different ideas, both kind of useful, some useful, some not very useful, but maybe very fun. That's exciting. And I guess this was even kind of more exciting in the sense that it had Lego inside the mixture. And when you look at some very funny, I would say, robotic thing that kind of is built of Lego blocks that holds a camera there. I mean, immediately it makes me smile. So it feels so good to kind of put together the thing that I was playing with as a child, with the technology that I kind of do my whole career, right? With like computer vision and Lego together. I mean, it's a really, really interesting mixture for me.
Right.
In terms of the submissions that we got, to be honest, I was not expecting this kind of distribution of ideas across industries. So I probably said it several times, but I love all these submissions, all the kind of ideas and projects and startups that are around agriculture and biology. And actually, kind of because I'm biased this way, I was expecting to have a lot of submissions around that. I myself had a couple of ideas on how I can apply Lego and computer vision in my own small greenhouse that I have at home to get rid of some bugs. Surprisingly, it was way more kind of centered around manufacturing and industrial technologies than I expected. But I guess that's great because again, I really think that robotics needs a real kind of some kickoff moment, because I thought it would be in some other kind of state of development than it is right now. Like in the past, I thought that it would develop faster, and obviously it is not. So maybe if the result of this competition goes into the industry itself, in the manufacturing pipelines, this would affect way more people than cleaning up bugs in my own greenhouse at home. So yeah.
Right. And for people who, I mean, some people may not know that Legos are very powerful for some of these experimentation. For example, one of the stories people tell at Google is that Larry Page, when he was a little kid, he built a printer out of Lego blocks. So you can do many sophisticated things with Legos. Now, should we go over some of the submissions of this competition just to see what people have, just to sample what people have submitted?
Yeah, sure. Yeah, Phil, please go.
Yeah, I can go ahead and share my screen here if we want to share the submission. That makes sense to you?
Yes.
Yeah. Okay. I'm gonna bring up Scan Nerf first because we all kind of talked about that before the show here, and so you should be able to see it now. So this one is really interesting to me because it's a I mean, Brandon, you were talking it up before the show. You want to talk a little bit about what you thought was cool about this?
Yeah, I think this is just so incredibly useful. So if you look at this, you get azimuth, so you get rotation around like this, and then you also get elevation, so you get the 90 degrees. So you can produce a full like upper hemispherical model of anything doing this, which is valuable in a slew of ways. Talking about like metaverse things, you can get 3D models, you can just do scanning. These are time synced cameras, so you can just produce really good 3D models out of it, if that's something that you're wanting to do. But
so Brandon, if you don't mind, could you describe what people are looking at so that Okay.
Yeah, absolutely. Sorry, I jumped right in it. Just blame it. I'm recovering from COVID, everyone. So I'll require a little bit of grace here. What this is showing is there's a rotating table. So you can place an object, say a Lego truck, on the table. And this will allow the object to fully rotate an azimuth. So to just like use spinning on the ground sort of thing. And then they're proposing a lifting device, which is say elevation or looking down from zenith. So that allows you to get a scan above the device going across. And of course, since the thing can rotate all the way around, you don't need to scan a full 180 degrees. You can just scan 90 since you have the other view from rotating an azimuth. And so what this allows you to do is either produce a 3D model, just for the purposes of having a 3D model of that thing. You can produce very clean scans out of this sort of technique. But perhaps more importantly, you can then use that 3D model for training data. Or even if you don't use that 3D model, you can actually just capture images and you have all three cameras And because it's a known background, then you can use OpenCV to remove the background from each of those images and then augment it on all sorts of different backgrounds. So say it's some object that you know, or it's produced and you're looking for defects or what have you. You can scan in these objects using this, have all the images, remove the background, augment on all sorts of different scenes in front of a beach or in front of whatever types of scenes that you would see. And since you have that controlled background, you can replace the background, but then you can also apply a ton of different image manipulations to the object itself only to make your neural model train across a variety of different scenes, different lighting, all sorts of things. And you have 3 points of vision of this object, RGB and grayscale, which then gives you even more data for training a neural network. So what you're looking at here looks like a fun thing that a kid might build. Maybe like Larry Page would build this as a kid, like a precocious child would build this. But when you actually look what it can do, you can generate very useful training data on the scale of tens of thousands of images that then are automatically augmented to millions of images across the permutations in the matter of maybe an hour, and just get a world-class AI model or object detector or semantic segmenter or what have you from this scanning device, which is just super cool. So showing 3D models here. The 3D models themselves are even more useful because then you could take these and say with the OpenCV AI Kit Unity integration, which is releasing now, you can then put these in 3D scenes and then use that to do synthetic training as well. So it just opens all these degrees of freedom to get a single object into a 3D space and then get millions of synthetic training images out of it. So you can produce insanely good neural models really quickly with Legos. And that's why I think this one's so cool.
I'd like to speak a bit about this paper. So when I opened it, I felt that it's not going to be a blind review, not even close, because I remember these guys. I remember ICANN team from the previous competition where they were one of the winners in European region. And to be honest, I was a bit afraid that I'm going to be biased towards them because their previous paper was one of my favorites across the competition, to be honest. And their previous, the previous solution of the for the competition. But I mean, this idea, I like this because it's at the same time is novel and close to what they did in the previous competition, kind of a very logical thing to do. So yeah, love this paper.
Anna, do we have experience in, we have thought about doing this in our consulting business also, right? Some of these ideas, some of similar ideas, not exactly the same, where you generate synthetic data without actually semi-synthetic data, right? It is in this domain where you use a system to capture a lot of data and then synthetically augment it. So this is not just, these techniques are actually used in the real world. Wouldn't you agree?
Totally, and it's immensely helpful to have a technique like that that is reliable and very easy to build and cheap.
Mm-hmm.
Yeah.
And one of these commodity tools, much more affordable. Bananas. Go ahead, Brandon.
Yeah, and I hope this is open source because I'll build it in my basement and scan all sorts of things. And to talk to this, when you're building data sets for known objects, like say if you're building a data set for an OAK-D light, if you have, and you want to make a OAK-D light recognize itself, which I think was Phil's idea, which I love that idea. If you have the full 3D renderings of this, you can make a 3D model in Unity, and then you can use that for a fully synthetic data set and to train. But in a lot of cases in manufacturing, let's just take this thing, for example, even if there are design files for this, usually this is a little like pocket scale. Usually they're fairly incomplete. And even if you have all the design data, you can't get like a perfect view of what this looks like in the real world. And so being able to scan back in a physical unit is incredibly useful, even if it's something you have design files for. in a lot of cases, you just don't have design files for things that you're wanting to train on because it's a cat, right? Or because it's, some other naturally occurring thing like a fruit. And so this allows you to get that into the metaverse, if you're to use the popular term of the day, to then generate this, semi-synthetic data.
Yeah, totally. It really surprises me that in the state of the art of 3D object reconstruction, for example, or 3D object re-identification or categorization, people still use a very old school data set that is called ShapeNet, right? Just because it's so hard to build CAD models for something more modern, kind of widespread and stuff like that. So people built this data set many years ago, and we still use that in the state of the art, which is surprising.
Yeah. Oh, and one additional point on this is we're starting to see in the literature that synthetic data sets in real world conditions, like when you're actually going to build something, are more powerful than real world data sets, just because you can permute so much faster. So this being able to do this hybrid where you take in something from the real world and then generate this huge synthetic is probably the most powerful of all of those. So yeah, I really can't express enough how excited I am about this. And I would really like the design files to start capturing and training on things.
We've talked a lot about how powerful the synthetic data can be on the show. Team Kata did a lot of simulation stuff for their digital twins project, and Joseph Nelson from RoboFlow is kind of always talking about that when he's on the show as well. Or Satya, would you like to say anything about ScanNerf here before we move on to another project?
I just want to bring up not the scanner per se, but about synthetic data. Recently, we did a bid for a project. It was an industrial project, but they had one video. They wanted to detect objects, track them, and they had given us one video as an example, or maybe 5 videos as an example, very small set. But we realized that these are industrial objects. And through that video, we could see, what is the rough shape of it. And we basically synthetically created our data set using Unreal Engine. We could have done it in Unity as well, but the person, our graphics person, was more comfortable with Unreal. So we generated this, and we actually showed them a demo with such little data. We were able to track the real object because we generated all this synthetic data. And similarly, in 2022, we will also write a blog post about a card, counting cards or detecting cards using synthetic data. So we have that data available right now. We are generating the code for it. So it's a very useful tool to have, especially in industrial applications when things are more controlled. So, go ahead.
I was gonna say something along those lines as well. So even for industrial applications, if you have a size down model that you built, you can just have it scanned without having the full production model, and then your machines in the factory will have the 3D information scaled out. So when this object is ready for you to use, you can actually make things happen right away instead of waiting for the full scale model to be in production before you can do anything. I mean, this is really powerful. And in the application, they also talked about this changeover problem in the industrial setting, which is very crucial. So if you have stuff in the assembly line or something, and you want to change to a different object, it's a huge cost to the company. And with this 3D information available, we can potentially do that automatically with robotic arms. So again, 100% this proposal is great, and I'm really excited to see what they can build with this.
That's agreed. Definitely. As a reminder, folks, we are using the Zoom Q&A functionality here. So if you have any questions during the show, just go ahead and hit that little button down there, type them out, and if they come up in the conversation, we'll ask them of our panelists here.
You did not mention our the giveaway this
you didn't pitch to me, Satya.
No, we should Intel and Microsoft Azure are sponsoring this, so we should be able to give out Azure credits. It may be in the first week of January. We may not be able to give it out immediately, but Azure credits, 200 hours of Azure credits, we should be able to give out.
Yeah, definitely. And we'll have a trivia question at the end of the webinar here. So stay tuned and you can have your opportunity to win some free Azure credits on Intel hardware. I'm going to bring up another one here that I think another project that everybody was pretty jazzed about. I definitely am. Pablito, the portraitist, which is a little pun, sort of. Pablito would mean little Pablo. It's a reference to Pablo Picasso. I'm going to zoom in so you can see a little bit better. There we go. Who would like to kick us off? Anna, could you kick off talking about this one? I know you love it.
Yeah, sure. I love that. So the project is about making a small, very cute robot that actually can draw a portrait. So it does that by using camera. It looks at the image, analyzes the image, and understands where its edges are. And then some magic comes into the play, and the robot starts moving with a pen on the paper and creates some form of art. So on the technological level, so I don't know how to do the magic about robotic movements, and that's basically why I call it magic. But everything else is pretty simple from my computer vision point of view. But I think this is exactly what kind of creates the people start to understand how this technology works with things like that. And also, I think it definitely can be a form of art. So I love this project because of how visual it can be if done right. And maybe, not maybe, I'm sure it will inspire people to do something with the technology that can do these things.
Yeah, would you like to say something about this one?
Yeah, actually, I love this project as well. Myself, I'm a hobby photographer, so I always love to see smart devices mounted on a camera. And in this case, the smart device is the camera itself. So there is a lot of possibilities that we can do with this the OP Light device. One of the things that I would love to see is a smart camera built out of the OP Light. Because the OP Light itself can do a lot of AI inference already, then we can automatically extract the scene parameters and have it take beautiful photography without having someone having 10 years of experience in photography. Basically, this will democratize photography for a lot of people, and it's just, I think it's the future for this type of thing. And this project is definitely the first step towards achieving that future.
Yeah, definitely. Brandon, thoughts?
Well said. I just think it's so cool. So Pierre, this is Pierre Mallick. He's applied to all the competitions. So this is the third competition. On the first, his submission was just blew us away. It was super cool. The second, also super cool, and in just the stuff that he's built in the meantime. I actually might not have even applied to the second, but he just did super cool stuff anyway. And then on this third, like when I saw this, I was like, oh, this is so cool. They referenced Pierre's GitHub. That's cool. And I was like, oh no, this is Pierre. Like, this is him doing it. And it's just, this would be so fun to play with. And speaking of that, like hour of code volunteering, anyone who's a programmer on here, if you can probably look it up in your area or start hour of code volunteering for elementary schools. This is the sort of thing that would be just so neat to have a first grader do, right? They set it up and you can show them like, look, the computer's understanding the edges, like it sees the edges, and then the robot's going to draw the edges, figure out some way for it to be interactive with them. But it's just such a cool combination of literally bringing into the physical world how a neural network is understanding an image, right? And I just think that's so neat.
Brandon, Pierre was the one who created the light gesture-based controllers, right?
Yeah, that's right.
The first competition, yes.
Yeah.
So I'm excited about this is that he's the kind of person who takes a small idea, but then pushes it to its limit, which he did with gesture-based controllers in the very first competition. I mean, if you think, what can you do with gesture-based controls, you would think about one or two ideas. I think he implemented 5 or 6 different ideas and very good implementations of each one of them in the first competition. So I'm really excited what he does with this one, because he does have that, knack for taking something which looks simple, but then he'll surprise you with all the various things, with the depth of the implementation, with the quality of implementation. So I'm really excited about this.
That's
one
extremely
other thing
well
is that
said.
I actually have, I had actually bought a robot like this for my kids 2-3 years back, which it doesn't have a camera, but it has a pen it holds, and you can program it so that it can go around and draw whatever you want to draw. So you have to program it or move such and such so many centimeters in front and then move right, etc. So this is going to be exciting.
Yeah,
there's some. Go ahead, Brandon.
To share what Pierre did in the first version, because it kind of gives the audience here an idea of how like OpenCV can perceive. So he used a predecessor of OpenCV, and he made touchless controls where you could turn anything in your house into a control. So like, to give this example, you'd be able to choose in his interface that you want this to be like the volume or light control, like just this random object. But if you moved here, it wouldn't do anything. Or if you got in the way, only if you like touched this object that you could do the volume control on your stereo or the lighting color or something, because it knows where your finger is, and this wouldn't do it either. And it knows where that object is. So it knows when you're touching it, and then it literally turns that into a control, which just feels like magic. It feels like something, when you watched original Iron Man and you were like, no one could ever do that, right? Like it had that feeling to it. And that's the power of, AI, computer vision combined with depth, and then someone who's just extremely persistent and creative to come up with these cool ideas and to make them into reality.
I guess I get the same kind of feeling of magic about both the solutions from Pierre. So this is amazing. About this one, I actually think that even though this is an idea that is implemented to its limit, it's not the limit. That's what I feel. I mean, it's probably only a start. So for starters, this is a single color, and I guess if you add more colors here, it would be amazing. And I think that multiple art styles can be applied here. So imagine if you combined something like, remember there is a state-of-the-art that in computer vision that applies a style to a picture, a style of some artist. And imagine if it could be immediately drawn. So I think this is just mind-blowing. Yeah,
and even the potential for using different media as well. So not just a Sharpie, you could use an actual brush or a fountain pen with some kind of thing attached to it. There's so much. Even just paint markers. Think about that. You could have it roll, stop to specifically make a blob, right? And then keep going to give it that kind of organic. It's really just extremely cool project, and really looking forward to seeing see how they pull it off.
Right, and in case people are thinking that, oh, why can't you just do this on a computer and print it out? Why does a robot need to do it? Think about, when if you want to make a floor graffiti or something that you want it at a very large scale, in that case, this thing can just go and, paint it instead of having a printer of that size.
Yeah, and you can put it on any media, right? Like this same methodology could be used on the side of a building with ropes as the motors on a rope instead of on wheels, right? And then you can really do any scale on any media, whether it's the surface as the media or what you're using, right? Is it spray paint? Is it oils? Is it something we can't even think of? Is it lasers, right? All sorts of permutations.
Stick a 1 watt laser on there and just start etching stuff. Yeah.
But if you do this at home, don't do it at home.
Phil did. I just like to remind everybody, I did not suggest you do that.
Yeah, and wear approved safety glasses at all times when you don't.
Can you not do that, right?
Yeah.
Well, yeah. Don't do it. But if you do, wear OSHA approved eyewear. Does anybody have a suggestion for the next one? Any project you want to call out, Anna? that we haven't looked at yet?
Yeah, so I would actually check out one of the projects that was about manufacturing and quality control.
Was it the spatial inspector? Is that the one? Prairie grasslands, I think. Let's grab this one here. This the one?
Yes.
Cool. There we go. Yeah, tell us about it.
So yeah, this is what I was talking about, bringing robotics into the manufacturing sites. Obviously, manufacturing sites are automated, but surprisingly many activities are still done by human eye, like tracking defects and finding defected bottles in this case. So the need of computer vision there is still very high. There are several things that kind of still stop computer vision from mass deployment there. First is fightable, I would say, and this is harsh environments that are there, right? There is a lot of dust, and sometimes the temperatures are not very system on a chip friendly, but this is something that we can work with. The other thing is that in many cases, these things are not, there is no use in only detecting the defects. You can then, you need to then move it, right? Or call a human to move it. But I mean, it doesn't ease the kind of problem if you need to call a human and human will move it. So ideally, these things, they need to have some robotic arm or ways to, move the defected product from there. And as I said, the lack of robotics in our real life kind of prohibits these type of solutions from happening. So this is one of the things about one of the things why I'm excited about these kind of solutions. This is not the only solution in this area that we not the only proposal in this area that we got, but I think this is the right problem to solve. Because again, we need to kickstart robotics.
Yeah,
that's great.
Brandon,
and here the depth
Satya,
is also being used, right?
Sorry?
And I hear depth is also being used to remove the product to find where it's
Yes.
located, and then. Okay.
Yes, of course, because for robotics, I mean, having depth is absolutely crucial because we not only need to understand the type of defect, right, to throw out basically the product, but we also need to grasp it, and to do that, we need to know everything about its position, size, and everything.
Yeah, and actually on the depth side, so it's really interesting as robotics are continue to advance, perceptions advancing, and so forth. Is there's this question of how do we perceive depth information, and do we need two eyes, do we need one eye, and so forth. And there'll like anything that ends up on the internet, there'll be fights about it. But one of the things that we've seen in animals and humans and so forth is that you can use a single eye and perceive depth, and humans actually do that. But if you look at as you push the limits of something, if something's moving fast or so forth, with a single eye using human intelligence, you can still figure out depth. But if you give a human two eyes, you can figure out depth a lot better. And so we're entering this similar convergence with depth sensing in robotics, which is if you have one eye, it's just a lot harder to be accurate. If you have two eyes, you can use these algorithmic techniques, which our brains do as well. But you can also apply intelligence to then get better depth results. And that's what we saw with ICANN actually in the previous competition, is using trinocular algorithmic and AI-based depth. In this application, you can take advantage of that same thing, which is it's really exciting to see that we're pushing the boundaries of what really humankind can do in robotics with these combinations and permutations. So it's really
opening
cool.
our third eye with computer vision. Also, it's really fun to say trinocular.
Trinocular, it's a cool word.
Extremely cool word.
So
Satya.
that's very well. I just want to add one thing that about human vision system, as Brandon had said, that it's actually not. I mean, we think that, oh, we are triangulating and getting the depth using triangulation, but that is only one component of it. We get depth through many different mechanisms. One of like even people with one eye can perceive depth to quite an extent. One of them is a depth through focus, right? How much effort it takes you to focus on a point gives you an estimate about the depth it is at. Then even with two eyes, it's the disparity is only one thing we use. We also use vergence, right? How the two, let's say if I'm trying to focus on this point with two eyes, how the eye muscles move to, focus the two eyes together. They also play a role in estimating the depth. And there are all these things, there are all this prior information that what an object should be, how big it is, like a soccer ball or something, right? So that information is also used by the eye to estimate the depth. So those are my 2 cents. I just wanted to put those things out there. There are multiple channels of depth estimation inside our visual system.
Yeah, and our visual systems are also really good at like kind of creating their own version of synthetic data in a way to kind of ease the two, to do a little easing between 2 points. So very, very interesting to me as well. Does anyone, let's before we move on here, or let's move on to the next project. Does anyone have one they'd like to suggest? I know most of the people here reviewed quite a few of these, so feel free to call it out. You got one?
Yeah, one of the most interesting projects that I reviewed is it uses the OP light to help with making sourdough bread. So I don't know if you're it was a really
the bread bot. Is that the one? Yeah. Okay, let me pull that one up. This one is really cool. As a person who lives in San Francisco, sourdough bread is very close to my heart. It's one of those things that is part of the city's kind of culture. Here we go. All right, tell us about this bread bot, yeah.
Yeah, so this is a very, very creative use of the technology here. So the proposal actually writes about how we can use the OP light to help monitor the development of the culture and whether to adjust one of the many different parameters for the culture to grow properly. And if you make sourdough, you probably know that there are, I don't know, many things that can determine the outcome. And with something like this, you can actually program your knowledge, your prior knowledge about how to make great sourdough bread into the system, so that it can actually do a lot of things automatically for you, so you don't have to constantly keep your eyes on this. Another part of this project is that it tries to apply this in an industrial level. So it says that it's actually able to help with mass scale food production. So if you right now, a lot of the sourdough bread or amazing sourdough bread is produced by small factories. But if we can apply this type of technology to a huge bread making factory, we can even make the bread much better for a lot more people. So again, this is an exciting project, and it's very creative use of Lego and the vision technology. I just can't wait to see the outcome.
I can't wait to try the sourdough.
Yep.
To taste the outcome.
Yes, exactly.
Yes.
Taste victory.
I wanted to share how I look at proposals like this one when I'm judging them. So I basically have two kind of entities fighting each other inside myself. The first one is the engineer, and the engineer says that it's completely impossible to do this in the proposed timeline. Like absolutely not even close. But I mean, some like visionary inside myself says, but this is the future. You need to do something to start moving there. So I think that we need to be absolutely conscious about the kind of trade-off between these two entities, right? Because I don't think that we will be able to kind of taste the real sourdough. I mean, after the proposal, I would be happy to be wrong about this after the kind of the competition, but I don't think that it's possible. But I think that this is moving in the exactly right direction. Please feel free
One of
to
the,
disagree with me if this is doable.
one of the things that I dug about this was, and I would encourage everybody for, the next time we do a competition, which of course we will, they actually put together a little waterfall plan here. Let me find it. There's an action. Yeah, here. This is as a reviewer, this is the stuff I love to see. Yeah, go ahead.
This is stuff that triggers my internal engineer and says, okay, these guys know their stuff. And if they propose that still, they do have a chance at succeeding. So
Absolutely.
Definitely makes sense to kind of talk with my internal engineer if you do a submission like that.
There are two wolves inside you. One of them is an engineer. Go ahead, Random.
Yeah, to your point of, trying, really ambitious things. So through my whole college career, I was a perfectionist. And so I'd always bid projects, like when you'd bite off a project that I knew I could accomplish. And looking back on my college career, I wish I would have failed a lot more. I didn't fail at any of them, right? And so like one of them, we had to make a robotic system. And back then it was incredibly crude, like computer vision was really difficult. You couldn't have it on a little robot. And it was playing dodgeball and we had the aspirations. I was like, man, I should make this wirelessly controlled as well. In addition to the algorithms that were doing things, like it'd be so cool to just have this wirelessly controlled. And I'm like, no, like, that was way too much scope. Now that's trivial. Back then it was actually pretty hard. Back in the early 2000s. And I wish I would have done it, right? Like, even if I failed, who cares, right? Like looking back on it now, I would have had this cool wireless robot in my basement instead of some dumb robot that has an algorithm that my kid can't play with, right? And so, on these, I think it is worthwhile, trying something that you might fail at the very least, share the results, share why it didn't work, and share a video of it shooting yeast everywhere when it's not working, right? And so I love the ambition and encourage people to, try something big on these.
Yeah, like
I totally agree. I mean, yes, sorry, Satya, please go.
Go ahead, Anna. Go ahead.
I mean, I totally love this attitude. I think it's important to kind of be very conscious about the real engineering effort that it's going to take and the chances of succeeding, right? And even if they are small, kind of putting it really like completely clearly into the proposal. So saying, okay, we know this is hard, but we believe in ourselves and we are super motivated. And because of that, we still want to try. And if we don't succeed, we will still do the kind of the first and second phase of the project that will still be very meaningful. I think this is the best way to go about this.
Totally agreed. Still having something to show, that's the most important part. Like, shoot for the moon, but if you miss, still be in a spaceship.
You will explode among the stars.
Yeah, still have a spaceship to be in when you miss.
I definitely agree with you guys that this project can potentially be very technically challenging. But something that we learned from our experience with the previous competition is that time management is exceptionally important. So you need to have a long-term goal where for this project is to automate the sourdough making process. But you also have to have a number of short-term goals that you can achieve weekly. So you can not only build momentum, but you can also advance towards your final goal and keep track of the progress. So what they have done here for the project plan is it's exactly what, in my opinion, what each team needs to do to keep things manageable. And anytime you stop, there's always something to demo. There's always something to show. So yeah, I absolutely agree with Brandon that we can. This is an exciting project, and in my opinion, it's very doable given that the plan that they laid out.
Right, and the other one more important thing that I want to highlight is, Cortic Tigers. You guys were doing a weekly update. I was looking forward to, when you to these weekly updates to see, what's new this week. And if people do that, it inspires not just their own team, it inspires the whole competition. And it's really useful when people have these weekly milestones and they are actually demonstrating what they are doing during these weekly milestones. So I hope that this submission also brings the same level of, they are also outputting it in public so that other people can look at it and be inspired.
I totally agree. I loved the weekly updates from Cortic, so thank you for that. It also made me feel as if I know you guys. So it made the whole thing not just abstract, but very personal. And I was kind of really rooting for you at the end of the competition because I really hope that you would achieve the goals. So I really recommend doing weekly updates.
Yeah, shout out to Team Kata as well, Gerard Espona, who still is doing weekly updates with theirs. Go ahead, Brandon.
Yeah, and you provided a great example of doing weekly updates on one side, and then on the other side, you provided a terrible example because everything you did worked, right? And so you were sharing, but every week you were sharing something that worked, and a really important part for everyone else who didn't just have things that worked every week, which means you must have had a lot of really, really late nights, I'm guessing, if you're anything like me. Then a really important thing is if your stuff doesn't work, share your failures, right? Obviously, that it wasn't the case for you, but that's a super important part too, for folks who are trying similar things or are curious, or just, I mean, a lot of engineers, especially early in my engineering career, after my first semester in engineering school, I was like, I'm not going to do this anymore, right? And it's just, I was doing fine, but it's just the amount of failure in engineering is insane, right? It's like 99% failure. And so share those failures, especially the funny ones. So on this one, I hope when stuff gets shot all around an apartment or a kitchen or what have you, trying to build this, share that failure, share what's not working. So I think that's one of the most important things, whether you're having success or not, just share what's going on. And then you can get some really interesting feedback. And at the very least, you'll help some other engineer or scientist or maker out there feel like, all right, I'm not alone on this, right? Like there is a lot of failure here. And I don't know what it was in the background. Maybe you're an atypical case. Maybe you didn't have any failures along the way, but I sure hope you did.
There's also something to be said for not just the psychological effect on everyone else. It's like, oh, thank God, other people's stuff doesn't work either. There's also something about I think sharing them helps you bounce back from them, because it can be brutal if you're just, especially engineering stuff like this, if you're just, I've been working on this for like a week solid and none of it works and I feel like it's never going to. But if you're kind of posting some of that, people can be like, we're with you. You can get your own kind of feedback from that as well. It's making me think that maybe next time, or maybe we'll work this in somehow in this competition, we should maybe have some kind of most impressive failure category or something.
Absolutely.
What did you blow up?
Yeah, like the biggest explosion.
Maybe a webinar with people just telling about their things that didn't work. It would be great.
Yes. That is a great idea, Anna. Maybe I'm going to put that on the calendar today.
Yeah. One thing I want to add is that OpenCV has a very, very vibrant community. So if you have something that you couldn't get working and you put it out there, somebody is going to talk to you and offer a solution for you. So we've had that happen to us before as well. So even though we didn't post a video for that, come to think of it, it might be great to do it. But again, the community is great. Just ask for help, always ask for help. And if you can help others, always do that as well. So that's it.
Quick question on that, Brandon. We had a problem on the Luxonis Discord channel last week. Have you moved on to a new channel, or what are we doing?
So we're still using Discord, and we will continue to use Discord. So it's one of these, every product has its like flaw or its blind spot. And what we learned with Discord is so independently to our issue, several of the folks we know in the community, their Discord servers were also hacked and their accounts were hacked. And so the background on that is Discord's a great platform. Like we were comparing against other online platforms, and some of them have like 17 reviews and like 3.7 stars. Discord has 2.4 million reviews on the iOS store alone and 4.8 stars. But they have a bit of a fatal flaw, which is probably exacerbated by the fact that they have such scale, is that any token, whenever you log in anywhere on any computer, is valid forever until you change your password. And so if you've logged into your Discord account anywhere and logged back out on any computer anywhere, if someone just knows about those tokens, they can use that token to then access your account ever, unless you've changed your password. And so that happened to a bunch of the folks we know in the community. That happened to one of our developers. And so then the technique that's used in Discord is someone will find that token and then do a phishing campaign against your community. And we caught that live in our community, that someone was trying to do that, and our engineer caught it and he was deleting all their messages. And so then that phisher got upset that he couldn't steal anyone's credit card information, and then just started deleting channels as fast as he could. And so he was just deleting information. And so all that was lost was just kind of annoyance for us, because there's a lot of posts that we have in there. But we've since then changed how we use Discord. So no one's an admin. So it makes it such that if the accounts get hacked, at most they can do is just get really frustrated that they didn't get an admin account. And so that's the flaw with Discord. But as long as you work around that with your own security protocols, which we're now doing, then you just have all the advantages. So speaking to support, we're super active in Discord. That was on Christmas Day. So within 7 minutes of that happening, we had it fully resolved and that guy kicked out. But in those 7 minutes, he was able to delete a bunch of channels. So we're very active in there. And if you do need help, Cortic Technology is in there, Geeks, Pierre Manjot is in there, our whole staff is in there, OpenCV's staff is in there, OpenCV.ai. So it's very friendly for helping folks, build things and understand APIs and brainstorm how to implement solutions.
Yeah, it's also just a great spot to hang out a little bit. I mean, there's cool people in there.
Yeah. And just so people know, when you was talking about OpenCV support, it's actually Luxonis support. I just want to give the credit where it is due. So
shout out to Carolina
Discord channel, which is very, very active, very useful for people getting support, especially if you are in the competition. Please join the channel and get as much help as you want.
Yeah,
so
we're coming up on time. You want to remind them what they'll win with our trivia questions, Satya?
Yeah, so the person who answers the trivia question first will receive 200 hours of free Microsoft Azure credits on Intel hardware. And now let's go ahead and ask the question.
Yeah, so if this is your first time joining us, or if you just need a reminder, the way this works is I'm going to ask a trivia question, which I've come up with based on the conversation we had during the show here. The very first person to answer that question correctly in the Zoom chat window, set to everyone, not just DMing it to me, will win this 200 hours of Microsoft Azure credits on Intel hardware, thanks to our generous sponsors. So get ready to answer. Team Cortic Tigers won the grand prize in OpenCV AI Competition 2021 with a smart Lego robot. What was that robot's name? I've been stumping them a couple times the last, I'm trying to make this an easy one. Nobody's got it yet. I see Bob, good guess, incorrect. Not the line name, the name of the robot. He had a specific name.
Yeah, someone's
Partha got it, but
he's not. We did not plan Partha. People might start thinking that
the goat.
He's an employee of OpenCV or something.
Yeah, we got
it. Give it to him. I think he's done it more than we denied him the prize one time already.
Yes, I think it's only fair. I also, yeah, we skipped a couple of weeks. But
right.
Man, what is just the we might need to retire Partha's jersey or something on these trivia answers. Yeah, so Partha, I already had your email. So in early January, we'll get in touch with the credits for Azure. They are duration based, and so they'll work from just like the credits for all the contest teams. They will work from early January to the end of the judging period. So we'll do that. We're heading up on time. Satya, you want to take us home?
Yeah, thank you so much for joining. I know this is 30th of December, and you are probably getting ready for the New Year's. Thank you so much for joining. Ye, Brandon, and Anna, thank you for joining us. And especially Anna, thank you so much for making sure that this, the judging was done properly. And this is really an incredible service to the community. And Brandon, I know the big work is ahead of you, and because your team will be the one supporting all the contestants in their journey forward. And of course, Ye, thank you so much for volunteering to do this work. Your experience in the prior competition will help a lot of competitors, and you will be in that channel as well to help out whoever needs help. Thank you. And Phil, thank you for nothing went wrong again. So that's great. And thanks for organizing all this.
Knock on wood.
I wish everybody a very happy new year, and may your dreams come alive this new year.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Intel and Microsoft Azure, sponsors of OpenCV Spatial AI Contest. Learn more at opencv.org. If you'd like to join us next week, register at opencv.live.